Hi everybody, so today's video is dealing with rational equations and distance equals rate times time problems, but these are a little bit more challenging because they actually involve adding a current either going with you or going against you. So let's just make sure we understand that if the boat is going upstream, we mean that it's going against the current. So the current is actually making it tougher for it. It's making it go slower, which means we're going to be using subtractant. We're going to have to subtract the current from our speed. And if we're going downstream means that we're going with the current, and which is going to make us go faster, which means we're going to have to add the current to the speed. But you know, books are kind of funny, the way they say the speed of the boat. So normally we say the rate is the speed, and we talk about speed or velocity. But when you have to add current to it, books usually refer to the speed as the speed of the boat in still water. That means the boat without any current, okay? So when we're referring to R in these D equals R times T problems when we're dealing with currents, I want you to remember that when you see the speed of the boat in still water, it just means R. All right, so let's look at an example. The excursion boat Holiday travels 35 kilometers upstream and then back again in 4 hours and 48 minutes. If the speed of the Holiday in still water is 15 kilometers an hour, what is the speed of the current? All right, so we're going upstream, so I'm going to say up, and we are going down. We've got D equals R times T. All right, well, I first have to make sure that I'm in hours, and right now I'm hours in minutes. So I'm going to convert that, and I'm going to do 48 divided by 60. Now, 48 divided by 60 is 0.8, so we've gone 4.8 hours. Now, the only reason I'm using a decimal here is because 0.8 is a finite decimal. It stops, it terminates. If I got a repeating decimal, I would probably choose to use a fraction and make the fraction a mixed number. But either way, this should work. All right, so the total time was 4 hours and 8 minutes. The distance upstream was 35, and the distance downstream was 35. The speed of the Holiday in still water is 15 kilometers, but now I've got to either add or subtract the speed of the current. So I'm going to let C equal the speed of the current. All right, so that means that I'm going to do 15. Upstream's going to be harder, so 15 minus C and 15 plus C. Okay, and the total time was 4.8. So if I say that this one was T time, then this one would have to be 4.8 minus T. Again, I'm using 0.8, but normally I wouldn't do that if it was like a repeating decimal. All right, so now I'm going to write my equations. And remember, you've got two variables, so you're going to have to use the modified form, D over R equals T. All right, so I've got 35 over 15 minus C, okay, is the first one, equals time. And my second equation is 35 over 15 plus C equals 4.8 minus T. Okay, so now this is where I can substitute this equation into the other. So I'm going to replace T over here with 35 over 15 minus T. So I get 35 over 15 plus C equals 4.8 minus 35 all over 15 minus C. All right, now, remember I said in the earlier video that some teachers will teach it where you add them up and they equal the total time. That is totally fine as well, okay? So you could do 35 over 15 plus C plus, it's really just adding this to the other side, 35 over 15 minus C equals 4.8. Okay, so now we've got to use that skill of clearing the fractions, okay? So we're going to multiply every single term by, and the left, by 15 plus C times 15 minus C. Remember, every term gets multiplied by the lowest common denominator. I know this is kind of messy. Okay, so let's do that. So the 15 plus c's cancel, and I get 35 times 15 minus c. Plus, then the 15 minus c's cancel, and I get 35 times 15 plus c equals, okay, hopefully you're noticing this is difference of two squares because they're the exact same. So that's going to give me 225 minus c squared, and I'm going to multiply that whole thing by 4.8. So grab that calculator, 225 times 4.8 gives me 1080 minus 4.8 c squared. Okay, got to distribute. I need to distribute over here. So I'm going to do 35 times 15, grabbing my calculator, so 525 minus 35c plus, I get another 525 minus 35c, I'm sorry, plus 35c equals 1080 minus 4.8c squared. Oh, this is actually looking pretty nice. The 35c's cancel. Then I got 525 times 2, which is 1050, equals 1080 minus 4.8c squared. Still looking pretty nice. There's no middle term. It's quadratic, but there's no middle term, so this is where I can use that handy-dandy square root method. So I'm going to subtract 1080 to both sides. And I'm going to get, what is that, negative 30? Okay, negative 30 equals negative 4.8 c squared, and then I'm going to divide by negative 4.8, okay, and I'm going to do that out, so 30 divided by 4.8 gives me 6.25. 6.25 equals c squared, and then I can take the square root of both sides. So the square root of 6.25 is 2.5. So the speed of the current is 2.5, and the units were in kilometers an hour, so 2.5 kilometers an hour. All right, guys, hope that was helpful. Have a great day.